really wondered what makes gold, well, gold? Or what makes the oxygen you're breathing right now so different from the carbon that's literally the backbone of life? It turns out, every single atom has its own unique ID, kind of like a cosmic fingerprint. And today, we're gonna figure out how to read it.
So what is it that truly makes an element itself? How in the world does the universe know the difference between an atom of gold and an atom of lead? You know, the answer is surprisingly simple, and it's written in this universal code. Let's crack it together.
All right, let's dive right in. The most important thing to get your head around is this. Every single element has a unique, unchangeable identifier, just like a fingerprint. And that's not just a cool metaphor. There is a literal number assigned to every element that defines exactly what it is. This number is the absolute core of its identity. If you change that number, you're not just tweaking the element, you are fundamentally changing it into something else entirely. So, what is this super important number? Well, it's called the atomic number, and it's the very first piece of our atomic code.
And here it is. An element's entire identity is decided by just one thing: how many protons it has in its nucleus. That's it. That one number, the atomic number, is the whole shebang. It's the simple, kind of elegant rule that lets us organize all of matter into the periodic table we all know. And this is an absolute, unbreakable rule of the universe. No two elements share an atomic number, which you have to admit makes it a perfect ID system. An atom with 1 proton? It's always hydrogen. An atom with 6, it's always carbon. No ifs, ands, or buts about it. So, for example, hydrogen has just 1 lonely proton, which gives it an atomic number of 1. Carbon, the very basis of life as we know it, has 6 protons, so its atomic number is 6. And the oxygen we're all breathing? Yep, it's got 8 protons for an atomic number of 8. The pattern is direct, and it's unbreakable. So you see, the atomic number isn't just some label we stick on an element. It is the element. If you could magically force another proton into a carbon atom, you wouldn't just have a heavier carbon. Nope. You'd have a completely new element, nitrogen. The identity is locked to that proton count. And getting this is the key to understanding everything from basic chemistry to nuclear physics. Okay, so we've totally nailed down identity. But that's only half the story. There's another important number that tells us not what an atom is, but how heavy it is. This is where atomic mass comes in. Now, the mass number is a totally different kind of count. It looks at the nucleus and does a head count of all the heavy particles in there. The protons we already know about, plus their neutral buddies, the neutrons. And the calculation is beautifully simple. You're gonna love this. You just count up the protons, count up the neutrons, and then you just add them together. That's it. Let's go back to our friend oxygen. A typical oxygen atom has 8 protons, and it usually has 8 neutrons. So you add them up, 8 plus 8 gives you a mass number of 16. It's just a simple way to measure how much stuff is packed into that atom. So maybe think of it this way. The atomic number tells you the element's name, while the mass number tells you its weight. It's just a really quick way to get a feel for the total heft packed into that tiny little nucleus. All right, let's put these two concepts right next to each other to really make sure the difference is clear. This is the main distinction you've got to know. Okay, so here's the bottom line. Atomic number counts only the protons, and that defines the element's identity. Mass number, on the other hand, counts both protons and neutrons, and that defines the atom's mass. It's really just identity versus weight. That is the fundamental difference. Okay, you've seen the theory, you've seen the examples. I think you're ready. Let's do a quick pop quiz to see if you've got this down. You ready? Let's just pretend we've discovered a new atom. We look at it, and our instruments tell us it has 11 protons and 12 neutrons hanging out in its nucleus. First question, what's its atomic number? Come on, you know this. Which particle is the one that sets the identity? If you said 11, you are absolutely correct. The atomic number is only the number of protons. Those 12 neutrons, they don't matter for this question. It's that simple. Nice. Okay, same atom, 11 protons, 12 neutrons. Now, for part 2, what's its mass number? Let's do the math. And for this one, all we do is add them together. 11 protons plus 12 neutrons gives us a total mass number of 23. See? You totally aced it. And that leaves us with one final,
and really fascinating question. We've established that an element's atomic number, its proton count, is its permanent ID. But what does it mean if you find two atoms of the very same element with the same identity, but they have different masses? What does that tell us about the building blocks of our universe? Well, that's a puzzle for next time.